In this video I will solve the puzzle bottoming out 2 and that is shown here. And what you see here is a semicircle with 2 inscribed orange squares and a blue square that shares a vertex with the left orange square over here, which is also on the semicircle, and there are 2 other vertices, one on the diameter and one also on the semicircle. And the question is what is the angle alpha over here, so the angle between these sides. And I will take the approach of the follower Stefan Bernard, and it goes as follows. It's a very elegant approach, I must say. First, let's make visible the vertices like this, and then first what you can see, of course, is that because it's a square, these sides are of equal length. That's obvious. What's also quite obvious is that the angle over here is a right angle, and then what you can see is that this angle HD, or what is it, HOD, of course is 135, because of course here you have a right angle and this is the diagonal of the square, so this is 45, and that makes 135 angle. And now we have a very nice configuration of a right isosceles triangle over here, so with 2 45 angles and a right angle, and a triangle which has an angle of 135, and that's exactly a configuration of a quarter circle. So you can draw, and I will show that, a quarter circle like this. It's quarter circle, so this is the whole circle and this is only a 90-degree angle of that, and every point on this circle has a 135 angle, which is quite easy to show. But now what we can see, and I will drag it over here, what you can see is that we have basically 2 circles, and the semicircle of course can be extended to the full circle, and these 2 circles they contain each other's center. So this circle contains the center of the lower one and vice versa, which means of course that they also have equal radius. So this radius of they both have the same radius, but that means that this common radius over here, because it exactly has the same length as those 2. So I put it like this. But of course we have here another radius of the lower circle. So, and now we are in business, because here DFO is an equilateral triangle, so it has 3 equal sides, and therefore it has also 3 equal angles of exactly 60 degrees. So we know that this angle FDO is 60 degrees, but of course we have here a 45-degree angle from the square, and therefore alpha must be the rest, so 60 minus 45 is 15 degrees. And that's the answer, so alpha is 15 degrees exactly.